Hi, I'm Mariana Osentoski, and I'm going to be going over video assignment 13 for chapter 7.3, trig substitution. So for our first question, we are asked to compute the integral of 1 over x squared, the square root of x squared plus 4 dx. And this chart will be very useful. It's from theorem 7.3.2 from the lecture notes. So here again is our equation and the chart. So looking at the chart in our equation, we can see that the square root of x squared plus 4 is also equal to the square root of a squared plus x squared. So we'll be using x equals a times tangent theta. So in our case, x will equal 2 tangent theta, and dx will equal 2 secant squared theta d theta. So with our initial equation, we can take and plug in the 2 tangent theta for x and the 2 secant squared theta d theta for our dx. Then we need to distribute the squares both in the denominator. Then within the square root in the denominator, we can pull out the 4. And with us pulling that out, we are left with a tangent squared theta plus 1, which is also equal to secant squared theta. And we can replace that. And then we can take the square root. With us taking the square root, we are left with 2 times the absolute value of secant theta. But the x values are positive, so we can just ignore the absolute value. We are left with this integral. So moving on, we can cancel out a 2 secant theta from the top and the bottom, and simplify to make it the integral of secant theta d theta over 4 tangent squared theta. Next, we can pull out the 1/4 in front of the integral. Secant squared on the top can be also written as 1 over cosine theta, and tangent theta can be rewritten as sine theta over cosine theta. Then we just replace those within our equation. Then we need to distribute the squares in the denominator. And then we can move sine squared theta and cosine squared theta out of the denominator by simply flipping it. Then we can cancel out a cosine from both parts. And we are left with 1/4 the integral of cosine theta over sine squared theta d theta. Moving on with that, we will use u substitution to finish solving. So we'll use that u equals sine theta and du is equal to cosine theta d theta. Plugging those in, we are left with 1/4 the integral of du over u squared. Solving for that integral, we find that it is equal to negative 1 over u plus c. Then we can go ahead and replace our u with sine theta again. And simplifying it, we end up with negative 1 over 4 sine theta plus c. 1 over sine theta can also be written as cosecant theta, so we can replace that and end up with negative cosecant theta over 4 plus c. Then we can use a reference triangle to finish out the problem. So with the reference triangle, our hypotenuse comes from the initial equation where we figured out which trig substitution we'd be using. So to find out cosecant, we will be using the hypotenuse over the opposite. So our cosecant theta will be equal to the square root of x squared plus 4 over x. Plugging that into our equation, we are left with the negative square root x squared plus 4 over 4x plus c, and that is our answer for part 1. For the second question, it is a true or false question with the statement, the integral of 1 over the square root of 9 minus t squared dt can be made easier to evaluate by using the substitution t equals 3 tangent theta. So looking at our chart from the beginning, we can see that the square root of 9 minus t squared is closely related to the square root of a squared minus x squared, which would mean that we're using t equals 3 sine theta, not 3 tangent theta. So this is false. Thank you for watching, and good luck on your final exam.